welcome to my YouTube channel, Math with Teens. Our topic for today is about the 6 trigonometric ratios: sine, cosine, tangent, secant, cosecant, and cotangent. Okay, let us now to discuss the parts of a right triangle in the 6 trigonometric ratios. So here, we have the triangle A, B, C, right angle at C. So if we have the angle A, the opposite of angle A is side A. Then the angle B, the opposite of the angle B is the side B. And the opposite of angle C is the hypotenuse side C. Okay, if we have the given theta here, the given reference angle, if we have the given reference angle is in angle B like this, so the parts of the triangle, the right triangles are, this will become the opposite. Okay, that is the opposite. This part, we call it adjacent because adjacent to the reference angle. And this one is the hypotenuse. Okay, the other right triangle, same right triangle, right angle at C. So our reference angle is in the angle A. So meaning, so where is the opposite? So this is the opposite side, and that is the side A. Then the adjacent is the side B. And the hypotenuse is also side C. So that will be the parts of the right triangle in the 6 trigonometric ratios. Okay, now, so what are the 6 trigonometric ratios? So first, we have the figure. So this is our reference angle. So again, this is the opposite, this is the adjacent, and this is the hypotenuse. When we say sine of theta, means sine theta is equal to the opposite. So opposite, this is the opposite over the hypotenuse. Okay? Opposite over the hypotenuse. Second one is the cosine of theta is equal to cosine theta. So we can say cosine theta is equal to the adjacent. So this is the adjacent over the hypotenuse. Tangent of theta is equal to tangent theta, and tangent theta is equal to the opposite. So opposite over the adjacent. Then we have to use the we call mnemonic. So we can remember this by calling as SOHCAHTOA. So how it became a SOHCAHTOA? So it became SOHCAHTOA because from the first letter of sign, that is S. Okay, S. Then O is opposite. And H is the hypotenuse. So that is SO. Now, how about the Ka? Ka. So C is cosine. A is adjacent. And H is the hypotenuse. So that is Ka. Then TOA. TOA comes from tangent. So T, tangent. O is the opposite. And A is the adjacent. So our mnemonic for this trigonometric ratio, the 3 trigonometric ratios, are SOHCAHTOA. So the other 3 is the other 3 ratios that we call the reciprocal of the ratios of the first 3. The reciprocal. So first, cosecant of theta is equal to the cosecant theta, or CSC, cosecant theta, is equal to the hypotenuse over the opposite. So if you will see that this is the reciprocal of the sine theta. Sine theta is opposite over hypotenuse. So now, cosecant is hypotenuse over the opposite. The fifth one is the secant of theta is equal to secant theta. So this is the reciprocal of the cosine. So if the cosine is adjacent over hypotenuse, so now secant is hypotenuse over the adjacent. And our last one is the cotangent of theta is equal to cotangent theta, shortcut, is equal to the reciprocal of tangent is the adjacent over the opposite. So let us recall first. Sine theta is equal to opposite over hypotenuse. So cosine theta is equal to adjacent over hypotenuse ka tangent theta is equal to opposite over adjacent TOA. So that is SOHCAHTOA. TOA. And the reciprocal of this is cosecant is equal to hypotenuse over opposite. Secant theta is equal to hypotenuse over adjacent. And cotangent theta is equal to adjacent over the opposite. So that's are the 6 trigonometric ratios. Okay, so let us have an example how to find the 6 trigonometric ratios. So we have the right triangle here. So we have the parts. This is the reference angle. So we have the adjacent, the opposite, and the hypotenuse. So in the adjacent, we have 3 units. The opposite is the 4 units, and the hypotenuse is x. Meaning, we need to find the value of x. What is the missing length? So we're going to use the Pythagorean theorem. So we have x is equal to the square root of 4 squared plus 3 squared. So 4 squared is 16 and the 3 squared is 9. So 16 plus 9 is equal to 25. And the square root of 25 is 5. Okay, so that our x now is 5. So what will be the sine theta? So our sine theta is opposite over the hypotenuse. So opposite is equal to 4 and hypotenuse is 5. So sine theta is 4 over 5. Cosine theta. So cosine theta is equal to adjacent. So this is the adjacent over the hypotenuse. So that's why we have 3 over 5. Tangent theta. So tangent theta is equal to opposite over the adjacent. So opposite is 4 and adjacent is 3. So 4 over 3. Cosecant theta. So cosecant theta is the reciprocal of this. So hypotenuse over the opposite. So this one, hypotenuse is 5 and the opposite is 4. So we have 5 over 4. And secant theta is equal to hypotenuse over the adjacent. So we know that the reciprocal of cosine is the secant theta. So where is the hypotenuse? So the hypotenuse is 5 and the adjacent is 3. That's why we have secant theta is 5 over 3. Okay, the last one is the cotangent theta. So cotangent theta is the reciprocal of tangent theta. So adjacent. So adjacent is 3 and the opposite is 4. That's why we have the cotangent theta is equal to 3 over 4. So that's our the example of the 6 trigonometric ratios. Okay, another example of 6 trigonometric ratios. So we have the right triangle A, B, C, right angle at C. So suppose we have segment AC is equal to 8, segment CB is equal to 6, and segment AB is our hypotenuse and that is x. So let us get the value of x by using Pythagorean theorem. So x is equal to the square root of 6 squared plus 8 squared. So 6 squared is 6 times 6 is 36. Then 8 squared is 8 times 8 is equal to 64. So 36 plus 64 is equal to 100. Then what is the square root of 100? So that is 10. So our x now is, side x now is 10. Suppose we have the given of sine theta, sine A. So what will be the sine A? Sine A, looking for the angle of A. So this is A. So A, so where is, sine is opposite over the hypotenuse. So opposite is 6. So this is 6. Okay. And the hypotenuse is 10. So that's why we have 6 over 10. Then find the lowest term and that will be divided by into 2. So it becomes 3 over 5. Okay, what is sine B? Sine B, look for the angle of B. So this is angle B. Where is the opposite? So the opposite is 8. Okay, 8. And the hypotenuse is 10. So that's why we have 8 over 10. Lowest term divided by into 2. So we have 4 over 5. Okay, the third one is cosine B. What is the cosine B? Look for the angle of B. Angle B. So cosine is adjacent. So the adjacent is 6, right? And the hypotenuse is 10. So we have 6 over 10, then the lowest term is 3 over 5. Yeah. Okay, number 4. Tangent A. So tangent A, look for the angle A. So tangent is the opposite adjacent. So the opposite is 6 and the adjacent is 8. So we have 6 over 8 divided by into 2. So we have 3 over 4. Cotangent A. So look again for the angle A. Yes, cotangent is the reciprocal of tangent, right? So cotangent A, so we have adjacent. So what is the adjacent? Adjacent is 8 and the opposite is 6. So we have 8 over 6. Then divided by into 2 to get the lowest term, and that will be 4 over 3rd. Yeah. Number 6, cosecant B. Cosecant B is the reciprocal of sine. Okay, so this is the angle B. So the cosecant B is the hypotenuse over the opposite. So hypotenuse is 10 and the opposite is 8. So we have 10 over 8 divided by into 2, so we have 5 over 4. Number 7 is secant A. So secant A is the reciprocal of the cosine, right? So secant A, look for the angle A. So adjacent over hypotenuse is the cosine. So the reciprocal is the hypotenuse over the adjacent. So it becomes 10 over 8. Then lowest term divided by into 2. So we have 5 over 4. Yeah. And number 8 is secant B. So what is secant B? Secant B is the reciprocal of the cosine. So we have hypotenuse over the adjacent. So look for the angle B. So hypotenuse is 10. Yes, 10 and the adjacent is 6. So we have 10 over 6. So the lowest term divided by into 2, we have 5 over 3. Okay. Did you understand, guys, the 6 trigonometric ratios? This is the how can we get the trigonometric ratios. Okay, guys, that's all for today. Our topic is the 6 trigonometric ratios. Thank you for watching and God bless.